Hello friends. When you're adding capacitors that are in parallel with one another, then the way that you find the equivalent capacitance is you just take the sum of the capacitances. And I'm going to show you now the derivation for getting that formula. You start with the loop rule, you start with Q equals CV, and you can actually derive the idea that you have to add the capacitances to get the equivalent capacitance when you have capacitors in parallel with one another. So we begin with a basic circuit where we have two capacitors that are in parallel with one another. The basic equation that we have, Q equals CV, of course. And so we can write this for total, right, for the equivalent capacitance and the equivalent total charge. So Q total equals C total, or C equivalent, times V bat, times the voltage on the battery. Okay, and we can also write this for each of the capacitors. So the charge on capacitor 1 is equal to the capacitance of capacitor 1 times the voltage on capacitor 1. And then same thing for capacitor 2, Q2 equals C2 times V2. What are the other things that we know? Well, keep in mind the loop rule is going to be really key here. And the loop rule tells us that through any loop in a circuit, the total voltage has to add to 0. So whatever the voltage is on the battery has to be the same voltage as what's on capacitor 1. Because I go through that loop, I go only through the battery and capacitor 1. And so the voltage on capacitor 1 has to be the same as the voltage on the battery. And the same is true when I go through capacitor 2. Come around. So that means the voltage on the battery is also equal to the voltage on capacitor 2. So I can write this, that V bat equals V1, which is equal to V2. So I'm just going to call that V. The other thing I know is that the charge on capacitor 1 plus the charge on capacitor 2 add up together to give me Q total. So Q total is equal to Q1 plus Q2. That's not how you write that, Q2. Okay, so now I'm going to take my equations from over here, and I'm going to plug them in to this equation. What that looks like when I'm done is this. So instead of Q total, I write C total times V bat, right? I'm substituting this in here, right? Equals, so instead of Q1, I'm going to substitute C1 V1. So C1 times V1 plus C2 times V2. Again, I'm just substituting this in for Q2. Now here's the thing that I know. I'm going to bring this up here. I also know that all the V's are equal to each other and just equal to V. That's what I found out here. And so I can write this. C total times V equals C1V plus C2V. If I divide everything by V, then all the V's cancel out. And I'm left with C total equals C1 plus C2. And there you have it. That's the derivation for adding capacitors that are in parallel. When you find equivalent capacitance for capacitors in parallel, you just take the sum of the individual capacitances. So thanks for watching. I hope that was helpful. Don't forget to like and subscribe.